Hello everyone. Today we are going to talk about one of the simple and powerful Google report which is disclosed by Jacob Domaraki. And this report is basically from Google BRP. Anyone can open this and it is public. The ultimate objective of going through this report is like you will be getting good idea how to try, what vulnerabilities can be tried, what to check basically. And this functionality is very common. The login with Google, the OAuth flow basically, which is a common login mechanism in most of the applications. So let's understand this report and let's try to follow that and apply it in our vulnerable in our hacking or in our bug bounties basically. So let's understand this report. So I'll try to post with a simple question here. So what if a simple mistake in checking a domain could allow attackers to steal the OAuth, the authorization code? Yeah, you heard it right. See, the problem here is how OAuth authorization code can be, extracted, and how that is achieved is based on origin bypass. Basically, the domain is not validated properly. So that's the main problem here. So we'll try to see first what is the OAuth. I will try to explain in a simple way. So OAuth is a system which used you can like click with login on websites or login with Facebook or login with GitLab or whatever. The authorization server is something different. So OAuth is a system when you click with login with Google on a website. Instead of sharing your password, Google provides a temporary token, and then that token will be used by the application and it will exchange the access token, and then you will be allowed to log in. So this is a simple OAuth flow. So even more clear, I just wanted to share you the OAuth login flow here. You can see a login with Google option. Once you click that, you can see the Google's login page, and then as a user you will be entering the credentials, and then you will be getting the authorization code, and then once you receive the authorization code, and application will exchange the code for the access token. So this is a normal OAuth flow here. Here you need to understand the authorization code is very important, and that's very sensitive. If attacker or if someone else gets this code, they may use it and they will get the access token on behalf of you, and they can access the user access account. So that's the important usage of the auth code. And the next thing which I wanted to talk about is there is something called the post message. Here you can see the researchers trying to redirect page developer connect google.com redirect and value of key origin using the post message target origin. What that means, you need to understand what is the post message here. So basically, when OAuth login happens, it often opens a pop-up window. I hope you have seen in many places, right? This pop-up needs to send the authorization code back to the main application, right? And that's the job which will be done by the post message here. So this post message will pass the authorization code back to the main application. So that's the that's way like the application will be verifying who's actually sent the message, who sent the authorization code. Application will validate it. If application is failed to validate that particular origin, that's where the problem comes up. So that's exactly we are going to talk about now. In this particular snippet, you can see that if in the if block origin dot ends with allowed origin, then the window opener, the post message, and the next step will be happening. Okay, so here they are simply validating the allowed origin. In this case, this researcher is talking about the codeassist.google.com, but eventually you can apply in your own bug bounty scenarios. It can be having different domains basically. So in this case, he's simply validating whether if the google.com is present, you simply allow. The developer just tried to check whether the message came from googledomain.com, but the strict origin validation is not there. That's the problem. So here attacker is creating or vulnerable domain that contains a google.com, but that's not originally a google.com. That origin is something different. So this particular validation, the above validation, can easily bypassed by this way. So you can see here attacker.com, codeassist.google.com. So this allows an attacker to create a malicious website that can impersonate codeassist.google.com. Okay, so this is a main problem. So this is the researcher's discovery here. Instead of using the codeassist.google.com, he created attacker.google.com, and that simply bypassed the validation here. So the validation only checking the domain ended with google.com. Because of that, the attacker domain can be easily pass the validation. So let's talk about the exploitation here. So they created exploitation, a simple code here. So this is something different. The researcher has created based on GitLab and few other domains here. Like there are some pre-assumptions already made, and based on that the researcher has created. But I'd like to put in a very simple terms here. So let's just think victim starts to log into the application, and then he's simply entering the OAuth, the credentials, and he's getting the OAuth code, and origin will be validated in this step basically. So in the origin validation, you can think like this origin validation can be bypassed by attacker controlled domain. That's where they can enter his particular domain with google.com, and then simply the validation will be bypassed. For that I have just created a simple JavaScript here. Let's try to see this validation here. I just try to create the same way what the original code was. If origin.ends with google.com, it will simply print the origin is trusted, otherwise it will not be trusted. So let's see this validation real quick. So I'm going to go back to the browser and open a new tab here, sorry, and then I'll click the inspect. I'll go to the console. So now let's copy our snippet here. Going to paste it, and then I'm going to enter it, and you can see the message origin is trusted. Why? Because the origin which we have given contains the codeassist.google.com. It will not even look for the complete codeassist.google.com. It will just check whether the google.com is present. Let's try to add few more validations here. So let's enter codeassist.google.com, and let's run the script. And still you can see that the origin is getting trusted. Okay, so how this can be validated? How can you do the strict origin validation? It's very simple. How you need to do is, like, you need to make sure exact validation like this. If this domain completely matches, then only it will say, it will allow. In this case you can see it is undefined. We don't see the trusted origin message because the validation is happening for the entire domain. So now let's change our constant origin like this. I'm going to remove the attacker.com, and let's run this script now. And you can see trusted origin again coming up. So this is the problem, core problem, which was identified in this report, and we need to think why this particular report is dangerous, right? You need to know the impact of the vulnerability here. So let's talk about that here. So the impact is basically about it can be the token can be exchanged. The code authorization code can be exchanged with the access token if someone is getting that right. Of course, the user account, they can access the user account and they can access the sensitive data of your application. So that's the main the problem. Let's think, if their authorization code is for some admin user, obviously they'll get the admin privileges on the application. So the root cause of the bug is very simple. It's about the origin validation. That's what we just saw now. How origin is ends with weakening the validation, and the exact origin validation will be prevent these kind of vulnerabilities. And what's the lesson, like the bug hunting lesson from this we need to know is, many vulnerabilities happens because of developers use weak string checks when validating the domains basically. And especially you need to check with this kind of methods, ends with or starts with or contains these kind of method which is vulnerable on the validation. So the final takeaway would show, I mean, which I am thinking is like, this bug shows even a small mistake in validating domain can create a serious security risk basically. If you're learning bug bounty, always check how application validating the origin, URL and domains. Many high impact vulnerabilities come from such a small validation. So I hope you liked this video. I request everyone to follow this methodology and apply in your bug bounty journey, and share any feedbacks if you have. So I'll try to improve, and thank you for watching and have a good day.